Hello guys, welcome to today's daily Leetcode challenge. Today we'll be solving question 1026, maximum difference between node and ancestor. Alright, medium level question. Let's get into the description. Given the root of a binary tree, find the maximum value v for which there exists different nodes a and b, where v is equal to the absolute difference of A and B, and A is an ancestor of B. Ancestor just means it appears further down on A, or ancestor means that it's a child or a distant child of some node, right? So a node A is an ancestor of B if either any of the child of A is equal to B, or any child of A is an ancestor of B. Okay, so, I mean, to me, this seems like, let's see, for for the node 8, everything is an ancestor. For node 3, anything that's below or a distant relative of 3 is an ancestor, but anything that's higher up the tree and then or in the parallel tree is not an ancestor. So, I mean, it seems like I can just pass down the minimum and the maximum value from or the current min and the current max for the whole tree starting with the root. I could be passing down the min and the max. That would tell me what for each node down the line, it would tell me what I have to work with. I can work with the minimum that appears either somewhere in the ancestor or the max. So okay, I think that v is just going to be equal to 0, and then def dfs node small large. This is just standard DFS code, but let me say that the smallest is going to be the min between smallest and smallest is just going to be the min between node val, and then a largest is going to be the max of node val and large. And then what do I just call DFS on left? Largest. I believe that's all I have to do, right? And then let's have non-local local v here, and let's call DFS with the root and return v. Yeah, believe that that's it. No, absolutely not it. First of all, root val and root val, but also what I'm not doing here is actually figuring out what my v has to be equal to, and v is just the max of the difference, right? So the max of v and largest minus smallest. So this gives me, for each node, it tells me, at the leaf of each, at every leaf, I know what is the smallest and the largest value that starts from the root and goes all the way down. And that's really what's important to me. On the path from the root to any leaf, what are the smallest and the most and the largest values, right? Because the reason why I have to know from the leaf to the root is because from a leaf to another leaf doesn't work, because two leaves are not ancestors of each other. Only a parent can be an ancestor to a leaf, right? So this time this should work. Largest minus smallest, and this new layout doesn't really run with me, but yeah, seems like we're doing good, and we're beating 48% of the submissions, but it kind of seems like we're still in the top percentile. Val if node val is smaller than small, else small. Let me try this. Node val if node val is large, else large. This could potentially work a bit faster because it's a simple condition rather than doing complex math. Beats 90%, yeah. So this is quite a bit faster, although the logic stays the same. So here, if you wanna be top 90 percentile, then use this approach. It's the same logic, just a bit different, different method for calculating the smallest and largest. Okay, well with that, let's end today's video. Thanks for sticking around, and I'll see you tomorrow. Don't forget to like and subscribe.